Hey, how's it going, everyone? Welcome on in. Wait, did I do this right? Are we good? Yeah, okay, good. All right. Hey, we're going to be building a tokenizer today for a large language model. I'm pretty excited about this because I found some pretty good efficient approaches to do this. We did a tokenizer a couple weeks ago. And hey, how's it going there, Ruchi? Hey, good to see you. Welcome on in. Happy Tuesday. We're building a tokenizer today for a large language model. We're going to build a better one than we built previously. We built a character letter tokenizer. That's pretty straightforward. That's pretty easy. You just take all the letters in your data set, your corpus, and then you find all the unique ones, and you've built your vocabulary. Done. Easy. We're going to be doing that today, except for differently. I found a really good approach that we can use with using regular expressions. I remember regular expressions. So we will be building our own tokenizer. I'm pretty excited about it. Well, I think it reduced my token problem, man. Oh yeah, it will. If you make tokens, that's the plan. We're gonna make tokens that are bigger. So not just like parts of words. We're gonna make all the, like this parsing will be one token, right? While will be one token, rather than it just being individual letters is what we were doing previously. First like, thank you, appreciate it. Good to have you here. All right, let's get started. All right, so I want to, all right, so where are we at here, LS? I'm going to close this. No, I want to leave that open because if I close that, then I'll have to redo a few things. So LS SRC, we're gonna touch the SRC tokenizer.rs and we're gonna start building it. That's what we're gonna do. All right. Hey, Soki, good to see you. Welcome on in. Happy Tuesday. We're going to be building a tokenizer today. Let me pull in all of my stuff over to a tokenizer. Source, tokenizer, paste that over there. And then we're going to build encoder, decoder. I'm going to put it over here. All right, tokenizer. Here we go. So we started this yesterday. Hey, Torva, good to see you. Welcome on in. Good to have you here. Happy Tuesday. Okay, so here's our tokenizer stuff. All right. Did we get everything? Is it all the stuff we got? All right, I think that's everything we need. So let's close that and let's get on our way to building a tokenizer. Use regex, I think so. I got your BG song reference. Yeah, you get the background song there. Yeah. I like this song. I like this song right here. It's one of my favorites. We played every single stream at the very beginning. Let me pull this back over here. Perfect. Bit frustrated. Oh no, what happened? You applied for an ML intern. They said I'd get back to you last Friday, but they haven't messaged you, so I haven't written an email to ask them what's up. Hey, Soki, and the initial interview was good. Well, I hope it works out. We were talking about doing an internship. However, I was talking to people on teams. They're like, we don't need extra help. Or they're saying if we added an intern, it would slow them down. And so like, what do we do? I don't know what to do there. Using your own BG song is the best way not to get copyrighted. Must say, there we go, Master Stroke. Thank you. Hey, Crafty, good to see you. Currently, I'm in India. All right, that's great. That's good to hear. Over there in Asia. Okay. So we're going to build a tokenizer today. We're going to build a tokenizer, and I'm not, does it char? Do we want a char? No, I want this, it's going to have to be a string is what we're going to have to do. It's going to have to be a string. I don't know if it can be, I think it has to be a string like this. I think it has to be a string like that. But however, before we do the word level tokenizer, we're going to do a letter level tokenizer, then we'll upgrade it. Sometime comment to get home run. Even I don't know how entertain your comment. Wait. Sometime my comment get home run. Even, oh yes, yeah, sometimes it's a good one. Yep. Sometimes, well, you know what? Any comment, eventually. You never know though. It could be a good one, or it could be ordinary. You never know. Okay. So I want to make sure that I can build this project. So I'm going to make sure that everything looks good here by opening my main file. And then we're going to, the thing is, simplified a token is a word, but there can be parts of words. There are one token. Yes, exactly. Yeah. You can have a token that's one letter, right? A one letter token. You could for made up words. They support it. We're gonna be building Tokenizer today. All right, so can this build? Cargo run. Yeah, there it goes. Okay, what did I print out? Oh, that's just the, wait, hold on. Did I print the data? Okay, I printed the data. I don't want to print the data. Let's bring this. Also, there was a cargo run that I could do to ignore the warnings. And I'd like to ignore the warnings for now. And we can clean those up later, right? I see sky with star. Why this not seems not on city. Crafty, I don't know. I don't know what you said there. Now you format your PC and your phone. Must say it feels lightweight because storage clean. Yeah, there you go. Hey, how's it going there, Shirazon? How's it going there, Shiraz? Good to see ya. Fable 5 being banned. Yeah, I did. Rust, ignore warnings. All right, there's like a little environmental variable. Here we go. Perfect, that's what I want. Okay. Boom, boom, gun. There we go. Clean, looks good, clean. All right, good. All right, mod tokenizer. Use tokenizer. There we go. Let's make sure that builds. All right, private struct. Oh, we can fix that. Pub. Boom. All right. Immediately. Oh, wait, another error. What do you mean? Oh, I have to bring this collections over here. There we go. There we go. All right. String, not string. Wait. String? Oh, yeah, right. Char for now. There we go. Wait, what do you mean char? What do you mean char is not? What do you mean? Where's it at? Blah, blah, blah. Here we go. That is not a thing. It's not a thing. Oh, new. Oh, no. Oh, got it. Hey, Peace Lord, good to see you. Welcome on in. Hello. Thanks. FIFA's going on. Soccer, right? The sports ball. Yeah, so wait, Fable 5 got banned because Amazon was able to jailbreak it. Right? They're like, oh, we have this model that's really powerful that can break security and, be scary. It can oh no, it's gonna break all the security things. And it did. Amazon found it. They reported it to the government. It's like they tattled. They're like, neener, they tattled. They tattled on them. They're like, hey, how's it going there, Junior? Good to see you. You're enthusiasm. Well, thank you. Appreciate it. Good to have you guys here. 2 best movies. First, 50 gigabytes, and the second, 75 gigabytes. I believe the quality. So you need both in 4K. There you go. Both in 4K. All right, so why is this broken? Char. That's the way I want it. That's the way I want it. I want it char. It's got to be char. Do I have to do this here? Right here. Yeah, that's correct, right? Like that right there. Expected one of while parsing the structure. We'll figure this out, you guys. Because they refused the government previous proposal. Simple as that. Oh, it was, yeah. Retaliation. It was. That's a good point. It was retaliation, wasn't it? Oh, you're right. Oh, I forgot about that. Do we not have to have this? Let's see. Can we do it this way, or is it gonna really want us to do that? Expected one. Oh, no. I know what the deal is here. Encoder, decoder, and then we're gonna have a vocab. This will be an I32 because it's not gonna be a very big vocab. It's gonna be a tiny vocab. See, we'll just say vocab is 10. Start like that. All right. Yes. Well, why is that not good? It should be good. Hey, Ghost Rider, good to see you. Have you been coding? Yes. How many years? I've been coding for over 25 years. I can tell you that. Don't worry, though. You don't need to code for that long to be able to get pretty good. All right, currently your hometown where the stars are clearly visible. A night sky. All right, I like that. See you in the city. In the city, it doesn't happen. You got it. Heard the case of the fable? Yes, heard the fable. We used it for 2 minutes and then it got banned. Hey, Quantified Quantum, good to see ya. Welcome on in. Happy Tuesday. Retaliation, simple. You got it, Peace Lord. That's what you figured it out. That was the answer. Heard some cases of fable point of view. Must say sometime the product overpower that. So much needed. I know, right? All right, so I think we can close this now. We are in this zone here. So we got our encoder, decoder. We're going to build a tokenizer today, you guys. We're building a tokenizer for a large language model. What programming language is this? This is Rust. Oh, I know, Torva, I know. It might have been Python because we've been doing Python for like 6 months. Now we're doing Rust. 25? Yeah, you got it. 25 years. Over 25 years. 315. Ooh, the lazy. Hey, Quantified Quantum, I remember you posted that video. You posted that video in Discord, you remember? Anthropic's far more accurate. It is. It's doing a really good job. I use it all the time. But you want to be alone. Crafty. Oh, no, wait. Hey, Mackie, how's it going? You are doing... Wait, I'm doing great. Thank you for asking. Thank you for asking. Where are we here? So, expected hash map I32 char. Oh, did I do this wrong? I did this wrong. So this is going to be the... I need to do this other way around. How about that? Oh, wait, no. Wait, okay, so encoder is going to be char I32. So I had it right the start. Here, right there. Encoder, char I32, decoder. It found bool type. No, you didn't. You found a hash map right there. You found it. Why does it say? Why does it say that differently? That's crazy. Here, maybe we don't need these guys. Hold on. My keystrokes are F. Okay, there we go. How about that? Okay, there. It knows what needs to happen now, apparently. First computer programming language is created by woman. Yeah, that's right, Ruchi. I remember that, right? Was it Ada? Was that Ada? Have you read the article I suggested, Stephen? What was the article, Peace Lord? I forgot. I don't know. I don't read that many articles, so probably not. Fell asleep at the beginning of the stream yesterday too. Did you? It's late. Yeah, we got a late stream today. Syntax looked blurry. Yeah, there you go. There you go. Anthropic CEO. Oh, I did not. I don't think, because I don't remember. I would have remembered. I remember the articles I read because I read only a few of them here and there. All right, so we got that working. So where are we here now? Okay. So we're going to create a new. We've got all of our characters. And then we need to loop through all of our characters and update our encoder and our decoder. Right? Okay, so actually what we should do, let mute encoder equals, here we go. And we're just gonna put encoder decoder here. Decoder. Then we need to do some looping. Hey, the Forts, good to see you. Welcome on in. Happy Tuesday. We're building a tokenizer for a large language model today. Your camera focus on your body, Mike, because I think there's much enough. What? The camera's right there. The camera's right there. Machine learn the machine of loving grace. Oh, I did not read that. I don't think I read it. Hey, how's it going there, Leaf Gang? Blum, blum, blum. You got it. Hey, welcome on in. Happy Tuesday. Good to have you here. We're building a large language model tokenizer today. All right, so we need to loop. So we have to loop over each of these chars. So we're gonna have to like iterate. Chars dot like maybe iter or something like that. We're gonna find out here in a second. All right, so for wait, what'd you say there, Crafty? Nah. Wait, what? Meow. All right, I figured it out. Hey, Beast Huntery, good to see you. Welcome on in. We're building a large language model tokenizer today. Okay. Token char. We can't call it a char because that's a reserved word. So We could call it a ch. How about character? Wait, character. There we go. Character, perfect, okay. Enumerate. There we go. Perfect. Let's see here. Leaf Gang. Danger plays once most dangerous plaything. Okay, all right, Leaf Gang. All right, I don't know what you're saying there, but all right. Is Rust functional? Soki, yes. Rust is functional. Supports closures and lambdas. It does. Focus on current people, more tokens than the model. Am I correct? If you notice current people more focus on tokens more than the model, yes, they do. They do. I mean, because that's what costs the money, right? The tokens cost the money. They do. They cost the money. So they're like, oh, it's all about the tokens. It's really not about the tokens. It's not. It's not so much. Yeah. So encoder dot. We need to insert. Let's type that correctly. Insert. Tell me, should I learn Rust? I would recommend, if you really want to. It's this day and age, what we're doing right now, typing our code by hand. Turns out the AIs will do that for you anyway, right? So what's the point? Do you really need to? You don't need to learn it. You want to learn it. If you want to learn it, then you can learn it, I think, at that point, right? If you have general understanding of architecture, I think you're good off. You don't need to memorize syntax anymore. So we're going to say encoder.insert. And we're going to say character and token. Right? Right. Wait. Let me check. So we got our characters. So we get a vect of char. So we token. This is going to be this is essentially the index right here. So let's do this. So this is going to be the index of the position of the character in our tokenizer. Right? And wait. There's extra things we have to do. We need to unique and sort. Otherwise we're gonna have problems with our tokenizer. All right. Sort and unique. UNIQUE. All right, to do. We gotta do this right here. Don't forget to remind me, you guys. Hey, Jay, bro, good to see you. Welcome on in. All right, you guys. Steven, do you think Python and Java, a bit of C++ is enough? Yes, I do. You're right, Soki. You're good. You're good to go. Why not use an LLM to build that so you can roleplay an AGI future? Rens. Yeah, I know, Ren. We're building it because we want to, because it's fun. Go engineers are rare and difficult to replace by AI. No, I think Golang is also really good complement for AI because it has really good compilation, right? It's got good compilation support. So Go and Rust are fantastic for AI engineers who use AI to generate code, right? You want to learn C? Do it. Do it. It's only like 30 so keywords. You're good to go. Prompt in JSON, it takes less tokens and better result. Yeah. So use function calling and tool use to get really good results. YOLO, computer vision, yes. Nice. Think you don't know, but you could code stuff by hand. Yeah, you don't need to, right? You just don't need to anymore. If it's not necessary. Although, are we doing it today? Yes, we are. Okay, so chars dot, it's called sort underscore not unordered. It's like sort. Let's look this up. Rust sort unstable. That's it. That's Rust sort unstable. Unstable, which is the default sort that you want to do in Rust, because Rust regular sort, you can do regular sort and it will do the same thing mostly. However, it will preserve order for unsorted items. So it's kind of like if you want to sort further. However, sort unstable is going to be an in-place stack-only based memory updates, which means it's going to be a lot faster, right? This is going to be faster than quick. And then chars.unique. Can I do that? Is there a unique for chars? Do you guys know? Rust is underrated, powerful, lightweight, and that is pretty good. It's a good one. Yeah, that's why we're doing it. 30 keywords and 900 pages. Yeah. Because there's so many design patterns, right? Torva, you got it. Code by hand's a lot of fun. Just feels better than using AI, doesn't it? I like it too. Here we go. All right, so we don't have a unique. However, we do. It's called dedupe. Dedupe. All right. Spell dedup. All right, dedup. There we go. All right, character. Okay, perfect. Now we've got little basic problems. Character token. Here we go. Okay. And then we need to do decoder and then swap these around, right? There we go. There we go. What's your comment on UK banning social media? Well, I think it's a mistake. I think it's a mistake. I'm pretty sure. Here, let me get the music going here. There we go. There we go. Because you're taking away from people's ability to do what they want. I mean, it's not like it's a carcinogen, right? I don't think it's a carcinogen. Productive, but you want to give higher AI, you need to be able to do it yourself so you can check the quality of the code. Soki? I think so. But you know what? The AI is getting so good, and within the next, it's already good enough. Let's just say that. Here, like, listen, I've got something to say. All right. So a lot of people are like, oh, the AI, it can't print, it can't do quality code. It doesn't give you the most optimal code. That's okay. That's completely fine. You don't need it. 99% of code written today does not need to be insanely optimized. It just needs to be good enough. It does. Only needs to be good enough. Beyond that, if you want to get the extra 1%, then you could go in and optimize it further. You can even ask the AI to optimize it for you. Will it get as good as a human? No. Most of the time it doesn't need to. Now you've solved for the extra 0.9%. Now that last basis point, the very final basis point, yes, a human can optimize it from there. Sure. That's it. There you go. There you go. Earphone wireless because harmful to ears. Oh wait, yeah, I don't have headphones myself. Hey, silly Bill. Hey, how's it going? Good to see you. I like your name. What you're making, by the way, we're doing a, what do you call this? Let me write this down for you. So today we're going to build a tokenizer for large language model. That's the plan for today. We're building a tokenizer. We're going to do a character level tokenizer first. Then we're going to jump in and make it a word-based tokenizer. So we're going to make it beefier, a little bit beefier tokenizer. Nested loops and if statements, if you want, right? Tips to impress a team as a fresher. I recommend computer vision is always impressive. If you can build like a generative AI model that can make images, that's a lot of fun. We did that live on stream a few months ago, remember? That's a good one. When you code with just, why would a company even ever hire you? Oh, I don't know now. I'm kind of worried about that because I said something the other day and people laughed at me. I was like, hey, wait, why are you laughing, you guys? I named someone the best engineer at the company by name. I'm like, hey, the best engineer at PubNub, blah, blah, blah. And they're like, what? They were like laughing at me. Like, Claude is clearly the best engineer at PubNub. I'm like, oh, what? Are you kidding me? No, don't think like that. You can't think like, but they are, you guys. They are. Oh, no. Oh, no. That's funny. Sorry, I had to say that. That happened. That really happened literally yesterday. Yeah. AI coding takes most of the fun out of it. I know it does, doesn't it? All the craftsmanship that you used to have by coding by hand, it's gone. It's all gone, you guys. It's gone forever. No, I don't want to do... I think I have to do copied, right? Does it want copied? Copied. And we do copied here as well. Is that good enough? usize cannot iterate. Cannot... Wait, oh. Well, oh, wait. This should be fine. It's just a value. It's just a number. Does it have to be an i64? Usize is not an iterate. So usize here. Let's do usize. How about that? Fine, usize. Make it usize. How about that? Usize, fine. Better? Character. Okay, character does need to be copied. All right. Copied. How about that? There we go. Char is not an iterator. Well, it iterator. Well, yeah, of course, char is not an iterator. Of course it's not. It should be a value though, right? Does it want, I'm missing an ampersand maybe. There we go. Hey, you guys, all right. Mutable chars. Boom! Hey, all right, okay. Little small wins. I mean, you silly Billy, what are you saying? Claude is an indirect engineer, right? As a light joke, please don't mind. Hey, it is, I know, right? It's not a real, it's a tool. It's a tool, not an engineer. An engineer is gonna solve problems and they're gonna use tools to do it. Some deep digging, find out our current AI models still need a lot of things to improve. They do, yeah, they do, you got it. Hey, Razorstone. But a man using AI for code takes most of the fun. Yeah, that's right. I read that already, but you're right. Writing code by hand is a lot more fun. It's a lot more fun. Okay, so where are we here? So we did that to do item. Did our new complete? Did we finish it? It looks like we're good. You solved, hey, Squirrel Sniper, good to see you. Solved AI. Hey there, Lex Furrer, good to have you here. Welcome on in. Squirrel Sniper, good to see you. We're building a tokenizer for a large language model today. All right, so we did the new, we need to do decode and decode. So pub, function, decode. Well, actually we'll do encode first. Encode first. And then we need a text and stir. And it's gonna return a tensor. All right, return a tensor, there we go. Lex Furrer, yes, yeah, that's what we're doing, you got it. Exactly, a tokenizer for a large language model, right? That's where that's where everyone's like, oh, the tokens, how many tokens are there? Because it's so expensive. All the tokens are so expensive, you guys. Let tokens equals, and then we're gonna do text dot, chars? How do we do this up here? Chars dot collects, okay. Chars, and then we need to map those. I notice YouTube live chat is wider on desktop in default mode or theater mode. Both have their live stream chat. Oh, yeah, Yep, yes, you got it. Yep, it's a different thing. I knew it, Squirrel Sniper, I knew it. I was waiting for your AI response there. Collect. Do we need to collect this? Not yet. We need to map over this. So we're gonna collect this. We need to map a few times to convert the character. Do we chars first, right? Chars.map. We're gonna convert the character to self. Wait. And self. Self.encoder. We say C, I think, right? Is that about correct? I think that's what we need. Oh wait, we can do filter map, I think, right? Filter map, because what that's gonna do, it's just gonna unwrap any options. So we're gonna do filter map. Verified forensic markers, Squirrel Sniper, yeah. You must name your AI PUBGPT. Hey, PUBG, yeah! I know, right? It's almost PUBG, but there's a T at the end, right? The arena-based game. Zero drift, I knew it, right? Absolute sovereign precision, Assembly make you a better programmer? Yes, I do. I agree that assembly helps you learn because it lets you know when system calls come into the picture. Like when you allocate on heap versus stack, you're gonna make an OS call to acquire more memory, which is slow, right? That's a slow thing. Lex Fur, watching your stream for a while. Oh, nice to hear. This cool stuff rather than just talking about some Fugizi and AI magic, blah, blah, blah. There's a lot of people out there. Yeah, we're actually gonna be building this stuff, you guys. Did this work? Encoder. All right, pub function encode. And then we need to return a tensor. Return tensor. Wait. We have to use TCH tensor. There we go. maybe kind. I don't know if we have to do that yet or not. Lex Furr, thank you for saying. And you're the only guy, yeah, rather than talking about it. I know. Thank you. Appreciate it. That's really nice for you to say. Thank you. From Slice tokens. There we go. All right. Did I do it? Is that good? Encoder. Oh, do I have to say It's not. Oh, wait. No. It's not encode. It's encoder. It's encoder right here. It's going to be encoder. All right. Encode, self.encode. Yeah. Copied. So, do I need to do that there? Okay. Pub struct tensor. Did I type that? Struct. Tokenizer. Not tensor. What? Does not satisfy iterator. Do I need to do an... let's see. Okay. Let's see here. Did I put this in the wrong spot? I might have. Unwrap. Okay. You don't trust the cloud-based AI, Scroll Sniper? Airlock gate treats every input as a threat. Yep. Keep all of your text on your own system. Do not let the AI companies take care of it for you. All right, let's build this tokenizer, you guys. All right. So why doesn't it like that? Maybe it's map filter? Did I type that wrong? I might have typed it wrong. No, I think it's filter map. I think we did this correct, right? Okay. Tokens, chars, filter map, char. Do I need to do an ampersand here, maybe? No, I need to do ampersand here. This is by reference. And then we create a copy. All right, let's try that. Better? No, still a problem. All right, so it doesn't want this. Fine. You can have it back. It's back there. It's yours. Take it back. Doesn't have a size known at compile time. There is a method filter map with a similar name. Oh, Fitler. You see what I did there? Fitler map. Hey, how's it going there, Erdem? Good to see you. Happy Tuesday. Welcome on in. Good to have you here. Hey, Chitter Royal as well. Good to have you here. You guys, everyone's here. This is great. Always best stream knowledge, man. Bye. All right, sounds good, Ruchi. Good to have you here. Oops, I didn't want to close that. Here we go. Okay. So we better now? Do I need to collect? I'm pretty sure I do. Encoder. I need, now that I took care of the other errors, can I do .copied now? Try explicitly collecting into a vec. You watching the FIFA World Cup? I might watch a few games, yeah. I might watch a few games. Today I'll implement some PyTorch code. Yes, Erdem! You should do that. You should do it, Erdem. Make it happen. Make it happen. Yeah, my subtitles sometimes are weird. Please feel free to ignore the weird subtitles. Okay. Where are we at here? I want to know why this is. So this is the character. So token chars character encoder. It's not encoder. Oh wait. Oh, I see you guys. You should have told me. All right. Here we go. That's a lot better. Right there. Okay. Here we go. Wait, maybe there's more to it. Do I need to... Yes, okay. Here we go. That's better. It's different. That's what it is. It's different now. Do we need to do an ampersand tensor? No, I don't think we do. It's just a regular ordinary tensor. Steven, know of encryption shards. Are you talking about like key splitting? Are you talking about key splitting? To be honest, I think engineers are now just filtering code and handling integration with iterations. Yeah, that's what they're doing now. It is actually what's happening. It is. It really is happening today. That's exactly how it is. At least at my company, I could tell you. At PubNub, we're just asking the AIs to write the code for us, and then we're just like plugging in places. We're like, code here, or we're like, code. We just organize code. They're like, oh, let me generate some code. I'm going to put it over here, generate more code, and put it over here. Like, we're just directing where code's going. Which school are you in? Rag Kumar, thank you for asking. All right, so those guys who are new here, thank you. Let's see, that's Todd Green, my co-founder, and I am Stephen Blum, CTO at PubNub. Zoom in on that real quick. All right, good to have you guys here. We raised $134 million for PubNub, which is a communications API company. We enable in-app communications. The top 10 the apps in the App Store today all have built-in app communication. Things like ordering food, seeing the car come towards you, on-demand delivery, chat, multiplayer games, things like that. Hey, Kyle, good to see you. Welcome on in. I am no longer in school, is what my answer is. Rag Kumar, not in school anymore. Doing some business now. Good to have you here. Suppose I copy all your codes into my PC. Will it burn my CPU? Nope, Jay, I think it'll be perfectly fine. It'll work out great. You will not have any problems with that, I think. I'm pretty sure. All right, so let me look through this. Chars, filter map, self-encoder. That's my encoder here. Yep. All right. Let me get rid of that. Encoder. Yep. Mm-hmm. And then we pass that in here. Yep, looks good. And then we should, here we go. This is something we need to take care of. Here we go. Charling. We need to do the length of the chars here. Something we got to do, you guys. Hey, Horse Hobbit, good to see you. Hello, friend. Hope you're doing well. Hope you're doing good too. Appreciate it. Thank you. Not software engineers, right? AI engineers. Cardum. Yeah, so you've got people who use AI to write code for them, and they could be engineers or not, and they are using AI like harnesses like Claude, Codex, Gemini, Cursor, you name it, whatever. They're using those tools to write code for them. They might not be engineers. However, there are engineers who are AI engineers, right? An AI engineer is someone who's going to be building AI, right? This is what we're doing right now, technically. We're technically an AI engineer today. And that's what we're doing today. We're AI engineering. Okay. Filter. Oh, wait. Use size. Maybe it's not what I want. What if I did I64? Could we do I64 instead? Maybe it likes it better if we I64 it. Iterator change to I64. Oh. Here we go. I don't want to do this, I don't think. Nope, don't want to do that. Okay. Can we go back to you? Maybe we want to stay U-size? Do you guys know? Hey, Loons, good to see you. Welcome on in. Happy Tuesday. Read my comment upward, please. All right, Rag Kumar, what'd you say really quick? Rag. Which school are you in is the last thing, and I'm not. I'm no longer in school. I've got a company. I spend time on it every day. 68 patent claims granted so far. This is my company here, PubNub. We're an API provider for communication. And we have over 1 billion devices connected on my network. 1 billion phones, you guys. You got the Quest. Oh, I thought you said your Quest 3 arrived. Oh, it got delayed. No. Can I call myself an AI engineer? I think, why not? Beast Hunter, all you got to do is write one line of AI code and you're good to go. Got to go. All right, Loons, thank you for saying hi. All right, so where is my challenge here? Vector of chars. So we're good here. Everything works here. We're all fine and dandy. There's nothing crazy. It would be nice if I could just do a U size. Token as I64. Okay. And is that good now? Did I get rid of that problem? type cannot be item 64. Yeah, it can. It absolutely can. This seems like it should work just fine. Breakthroughs, completely new innovations. Ooh, Squirrel Sniper! That sounds exciting. I mean, which school are you graduate? Oh, I'm not. I dropped out. I dropped out of school. Ah, there you go. I didn't finish college. I went for 3.5 years. So I didn't finish. I went into business instead is what I'm like, hey, if I was to graduate, what would I do? I was like, well, I'd be running my business. Okay, well, what if I didn't graduate? I'd be running my business. It was the same answer either way. Yeah, so it was, I went to a few universities here in United States. A few universities in the United States. Here we go. They're listed. You can see here. They're listed. You can look. They're on my LinkedIn if you want to find out. All right there, you guys. Right there. Okay. But I didn't finish. So, all right, cannot be built from. It's most certainly can. Okay. I just need to figure out what's wrong with this. All right, this expression has type and stir. Didn't we, it's 38? Hold on, 38, GG. Yeah, encode, okay, here. Let's just get rid of this for a second. Make sure that we're on initially good standing. There, see, okay. So all of my problems are in here. Kyle, how's your day? If you're talking to me, my day is good. Had a good morning, a lot of good stats and numbers up and to the right. We're like, oh, look at that. So I'm seeing some good things happening. And so now we're building a tokenizer for a large language model. So I'm going to hide this stuff here. There we go. Yeah. Then we're going to say return nothing. Can we build that? Refine? All right. Then we'll return tensor. It's going to crash because it's like, hey, you didn't return a tensor. So we will say tensor from slice. We go and 1, 2, 3. Try that. All right, good. All right. Awesome. Yeah, I think it's great. So what do you really do for a company? So I'm the CTO. I work with teams at the company today. We've got a bunch of different teams, engineering teams. We've got sales teams, marketing teams. I chat with everyone. I'm building and innovating in automation. So I'm helping increase the ease of adoption of AI in the company right now as well. So I'm helping accelerate our teammates doing that right now, building technologies that integrate with intelligence tools like Claude and Codex and Cursor. And we're being I'm very satisfied with what I'm doing right now. I was very happy. I also talk with customers and I help debug problems because I've got the entire architecture memorized, right? So I can find where problems are. Bad comment? I know, good comment. I think we're good. So yeah, I do a lot of things throughout the day. And I stream here to learn and educate myself on the world. And you guys help me along the way. You guys help me. All right, there's Squirrel Sniper. I knew it. Always can depend on you. I knew it. Okay, so here we go. I want to... So here, check this out up here. So I tokenized these already. All right, so 1 second, chars. So we don't need to mute the chars. Not anymore. We don't need to mute the chars. So here we go. So chars, we're gonna call these tokens. We're gonna be a vec of chars. And we're gonna collect them. Although, wait, no. It's not a vec of chars anymore. It's a vec of I64, right? So we can do this, and we don't need it. It's not mutable. We don't need to mutate it. So then we really just need to say this, right? Just like that. Using PubNub in 3 places in your app. Oh, that's amazing! Hey Kyle, what we're seeing it's pretty great. What you're describing right now, you're building really important interactive features. And we're seeing a lot of companies starting to do this now. Who is the gang? Hey, Alexander, good to see ya. I don't know. Who's the gang? What do you mean? Eminem, good to see ya. You look very much like a robot with skin. Well, I mean, I'm trying to gain weight. Don't get me wrong. I'm eating a lot of food. I just don't gain weight very easily. Okay. So thank you for asking, Eminem. Good to have you here. Is this going to be happier now? Tokens. Okay. How about ampersand? Can we do? Wait, no, that will not work. That will not work. Oh, wait, will it though? It might. This might work. Here we go. How about that? Let's do comments out. All right, did we win? Oh, we did it! Finally, it only took us forever. Hey, there we go. And do we want to keep it i64 or U-size? Do you guys know? What's the best? All right, Google i64 versus U-size Rust. Let's find out. Yep. My U-size equals. Yeah, I know. What's the difference? Let's figure this out, you guys. Keep the comments thoughtful, please, you guys. All right, thank you, Kyle. I would love you to read and review my white papers, Steven. Hey, Squirrel Sniper, those white papers have all the words that you're saying on a regular basis. And what I would love to see is a white paper that uses ordinary English. I understand, for the most part, what they're saying in those archived papers. It's just too too much flower text. It's way too much flower text. He's Googling from Vim. Who is this guy? Alexander, I know, right? Unsafe. All right, safety, unsafe. Keyword as unsafe. Can truncate a wrap from into. Yeah. Okay, so I want. Let's see. Compare table format U-size versus i64 Rust. I have that now, Squirrel Sniper. All right, sounds good. All right, so what do we got here? Unsigned integer, signed integer, platform dependent, fixed, minimum value, negative, maximum value, 32, okay. All right, so we don't need numbers that big. So we should just do U-size for everything, right? U-size for everything. Okay, I'm gonna try changing this. U-size, let's go i64. Hold on. I-64, thank you. U-size, no. U-size, there we go. Any others? No. Do we need to do this now, or is that gonna be automatic? All right. I might need to bring it back to I-64. Okay. It doesn't like it. It wants I-64. All right, fine, we'll do it. Kind element is not implemented for U-size. All right, so it needs to be I-64 because Torch Library wants it to be I-64. All right, that's not how things work. You have to understand that, or no, Alexander. I mean, oh wait. Are you guys talking to Squirrel Sniper? Here, let's bring everything back to I-64. Okay, there we go. All right, success. Yep. Here we go. Wait, why is that? Got it. Okay. There we go. Okay. Green. There we go. You have some intelligence to intuitively combine Legos. So you can stack Legos together? What do you mean? It's pretty easy to put them together. You mean without following the installation guide for like building a specific... Go. And we will do this the Rustish way. It's good to me. Okay. Let us do a chars. Is it chars? Did we do chars up here? Yeah, we did chars dot length dot len as I-64. Is that gonna work? It is. It's gonna work. All right. Looking good to me. Okay. Now we need to do the hard part. Although it would be fun to actually just use the tokenizer really quick, right? Maybe we could just use the tokenizer just for a little bit, just for a smidgen, right? Hey, Goko, good to see you. We're doing good. Thank you for asking. Happy Tuesday. Good to have you here. All right, let's split the window here. Control W. There we go. No. Vertical. Main. Okay. So we got our tokenizer. We're good to go there. Got our torch. We got our anyhow tokenizer. Then I want to. So this is currently part we're doing this part right here. So we did the data loader. Now we're going to do tokenizer. Then we won't do batch and shuffle until like the very end, until we start getting to training here. So we'll do training. All right. Bounded bit mask architecture. See, it's a thing. Local state reconstruction. All right. Let me get my tokenizer. What should we call this? I guess we could call this our encoder. No, dictionary. Here we go. Dictionary. That's a good word. Equals tokenizer new, and then we pass in our data. It's a text data, which might require us to do something different other than text. Maybe, I don't know. Maybe text data implements an answer. You never know. Hey, how's it going there, Dado? Good to see you, Dado. Welcome on in. Happy Tuesday. Thank you for clicking hi. All right, let's keep going, you guys. So let me see if this works. New. Is it going to say it didn't like the data? All right, found an A string. All right, so text data. What type is this? How do I capture it? Can I convert text data into a string? What's the way to use this? Do you guys know? All right, text data is a torch data thing right there. Oh, is this Vim? Yeah, you got it, Dado. This is Vim. You got it. Thank you for the hearts, you guys. Appreciate it. Good to have you here. All right, let's get our song. Let's get our next song going here, you guys. All right, here we go. Get the song going. Boom. All right. Good. Okay. Thank you for the hearts. Appreciate it, guys. You don't know? Kyle doesn't know, you guys. All right, so I want to... I'm curious. All right, so let us learn about text data really quick. So I want to do a quick little search here. This guy's a genius, Alexander. Whoa, thank you. That's very nice. If I was a genius enough, I have to do some lookups. there's some things I don't know. There's just a few things. We have to Google for torch, TCH, Rust, text data. All right. I will switch to PC. All right, sounds good. Switch them up to PC. If you want, we've got the horizontal and vertical, right? So you get the horizontal over here on left, vertical in there. And that is, the vertical is on YouTube and the horizontal is on Twitch. Nice, a genius. Well, Kyle, thank you. Here we go. Switch. So if you want, we're on Twitch also. Okay. So, text data. Yep, looks good. Data.labels. See, now this is weird. Get the number of unique characters for the model's output layer. Whoa. Wait. Number of labels. How is it going to get the number of unique characters for the model's output layer? Are you serious? Are you kidding me? Is that a thing? No way. We have to try that out right now. That is amazing. All right. Print ln exclamation point. And we're going to say I want the data.labels. There we go. What does that look like? Whoop. There we go. Oh my goodness. Oh my goodness. That's really okay. I didn't know you could do that. I didn't know, you guys. I didn't know. That's crazy. He can be focused for 2 seconds only. I know. Only for 2 seconds. Infinite mirror is cool. Infinite mirrors are pretty cool. Thank you, Kyle. I do appreciate it. He's a genius. Thank you. Steve and Just Me, or do the new websites that are generated to feel kind of not smooth? Yeah, they're very choppy, they're slow, and they do not take into regard any of the performance. You got it. You're right, Torva. Behind the scenes, partially codes them. That makes them faster. You got it. The stuff gets so complicated fast. Learn and practice, but grow in business as well. A different level. It's a different level. The Lighthouse scores of 9F, some of those feel, you see 29 megabytes of images in JavaScript, and yeah, sometimes there's a gigabyte of JavaScript, which is a big problem. Okay, so can we capture the text data as string? Can we do that? Can we get text data as string? Is that something that we can do? All right, get text data as answer. I want an answer, if you please. Convert it to an answer. You cannot directly extract the original raw text or string from the text data instance. Why not? Well, then how do I consume it? How do I consume it, you guys? Raw text, file system. All right, so let's get raw text. All right, we're gonna switch it up. Our data is now gonna be raw text. So we're gonna do it differently. Okay. So data equals, we're going to call it a string. So this is training data. And here, actually what we're going to do is we're going to comment this out. String, we're going to say fs, the read to string, okay. Question mark. Yep, looks good. Okay. Close this so I can read the whole thing. Bro, do you have a vocabulary for your words? We're building one. Yeah, we're building one. Yes. So check this out. I have a file here called, where to go? Data. So I've got a file called data training right there. And we're going to load that in, and we're going to parse it. And we're going to generate the vocabulary. The corpus is there. Tuple is simple but nice. I like the tuples. Only prior to, yes, exactly. See, Kyle, you are like a tried and true engineer when you say that. Yes. So you guys, you don't want to prematurely optimize. You don't. You want to save that until after, because you might just throw away large chunks of the code anyway. So there's no point to prematurely optimize. You want to optimize when you know it's time to optimize. Hey, Oxnell, good to see ya. Welcome on in, Google alias. Yeah, Oxnell, thank you. Hey, Bros, good to see you. Welcome on in. Happy Tuesday. Good to have you here. All right, let's keep going, you guys. All right, training data. We're reading it in, and let's print out the length. Can we print out the length? Is that going to work? All right. Let's bring this back over here. Run it. All right, so we're going to use standard file system. Looks good. Looks good to me. Excellent. Okay. Hey, there we go. That's what I'm looking for. All right. So now we can get our dictionary and our tokenizer, and our data is exactly what we want. And string. Is that good enough? Private. It's not. Oh, whoops. We can fix that. Hey, Laura Maxwell. Good to see you. Welcome on in. Happy Tuesday. Good to have you here. Welcome on in. All right, so let's see, pub. Do we have to say pub here as well? Do you guys know we have to do that? I don't think we have to do that. It doesn't matter, because you don't need to pub the implement. You already know the tokenizer is already public through a struct right there. Right there. Boom, done, easy. All right. Now we can use our encoder, you guys. Okay. So let's see. Let's see here. I want to see tokens. Tokens equals. It's going to be a tensor. I'm going to say dictionary dot encode data. We'll send the data there. Wait. Here we go. Okay. Then we're going to say print. No. Tokens dot print. There we go. That's what we want to do. Because it's going to do a nice little built-in printer. Because it's going to make it look really nice for us. It's really nice. Nice little built-in printer. Thank you, libtorch. Here we go. Boom. And look at all of our tokens. Look at that. Okay. This is great. This is fantastic. We should probably have reserved the 0 token. So we got to reserve the 0 token as a pad. When word embeddings will start? Oh, we might do word embeddings tomorrow. So we've got here our tasks here. So we're currently on Tokenizer. Tomorrow we'll do embeddings. Today we're going to do a character level tokenizer, and then we're going to upgrade it to a word level tokenizer. Make it looking good. Order operations after launching is super important. It is. Wasting so much time optimizing things that get scrapped. Yeah, you got it. Bojan, how's it going there, Bojan? Thank you. What motivates you, inspires you to learn and build the things you do? Well, this is like really exciting stuff. What we're building right now is a large language model in Rust using an accelerator framework for our GPU called libtorch, the TCH library, right? TCH right here. Nice, easy to use, helps us put all of our workloads onto the GPU. Yeah, make it fast. Go burr. Go burr, you guys. Okay. Let me grab some water real quick. There you go. You got the starting point, Ashish. Yep, I saw what you did there. You're doing some code. You got yourself a for loop there. Okay, so we no longer need that. Text data gone. Boom, not needed. Pretty sure. Beautifully put. Oh, thank you. Glad to hear it. All right, so let's get that. Yep, looking good. Okay. That's on the CPU, which is fine. We'll get a device later. We can always move that over to the device when we're ready. We say that tokens equal tokens.toDevice. Can we do this? Device? Can we say that? Can we do it this way? This is what I want to do instead. I want to do that. Is that going to mutate it? Will that mutate it? I think it needs to be variable shadow. This is going to fail compilation. Oh, what? It didn't. But it also did not work. It did. Oh, no. Here. There. It still didn't mutate it. Okay. So let's try doing this. There we go. No, it still says CPU. It still says CPU, you guys. For int count. I love Stephen Blum. Hey, there you go. Wait. Is that like infinity? I equals 1 while I is greater than 0. I plus plus. I love Stephen Blum infinity. Infinity. That's nice. Thank you. That's really nice for you to say. It makes me happy. Very much appreciated. So wait. Is that going to do what I want? Oh, there it is. See. Right there. That's what we wanted. MPS means that it's running on my GPU, my graphics processing unit. Who won the hackathon? Epic Bloxpo, good to see ya. We had our hackathon winners. It is in the hackathon channel real quick. Hackathon. Here we go. Where's our winners at? We have our winners right here. Congratulations, Bloxa AI hackathon winners. AI agent that creates other AI agents, which is pretty neat, right? AI agent that redacts personally identifiable information. And then an AI agent that performs electromagnetic radiation calculations for astronomers. Those astronomers, you guys. Got those winners right there. They got the prize, all the payouts, they're good to go. Okay, so now I want, let me see here. Let me put everything down at the bottom. All right, how many characters we got? Okay. Now that we've got our encoder, let's make a decoder. Yeah, make a decoder next. And then after that, we're going to upgrade the decoder and encoder to be a word-based encoder, right? A little bit more word-based. Okay. So now that we've got this here, we need to implement the decoder side of it. So let's do that. So we've got our encoder. We're going to do a decoder pub function decode and self. And what is the input? It's going to be a tensor, right? And it's also going to be like a batch of tensors eventually, right? So it's going to be a batch of logits. So right now we need what do we call this? Output as a tensor. Can we do that? And then the response is going to be a string. There we go. Brother, why we use RLHF? Because human beings give feedback on wrong output. What is RLHF? Google RLHF acronym. What is that? Reinforcement learning for human feedback. Oh, yeah. Okay. Why do we use reinforcement learning for human feedback? Because humans give good feedback. They give good feedback, yeah, on wrong output. Sometimes they do. And sometimes they do. Here's the deal, though. It's actually pretty straightforward. If you have 10 humans and one of them's wrong and 9 of them are correct, your model will learn more from the 9. Right? So it's okay to have that noise. It's okay to have the noise. Okay. Okay. So we're gonna have to. So we got to take our output. Tokens, and we need to identify what the token format's going to be. So it's going to be batch, sequence, and logits, right? Or I guess probs. Probability of which the potential token's going to be, right? So before we do that though, let's just get them regular tokens. So a simple array, a vector basically. So this needs to be a to-do. To-do. What if 9 of them are wrong and only one of them is correct? Well, then you get bad data. That's right. If all of them are wrong, then you get really bad data. Don't worry. You can go back and check it later. And they do. They constantly go back and check that the quality of their data is good. All right. Tokens dot iter dot. We got it. So what are we doing here? So we can't do chars. We have to iterate on each of the values inside the tensor. Do we also have to bring it back to CPU? We need to iterate. So wait, let's see here. Google iter on tensor tch Rust. See how we do that. It's been a while since how do you iterate on a tch Rust? Okay. Oh my goodness. Okay, so we have to convert it into something here. An array. Can we do it just as a vec? How about a vec? Use vec. Q learning in large language models, if no role, the way we are studying traditional AI. Okay, now I understand. Okay, now another question. What is the role of Q learning? Q learning. Popular model, free reinforcement learning algorithm. It trains an agent to make optimal decisions by interacting with its environment through trial and error. So wait, what's the difference between Q learning and reinforcement learning? It learns with values of thinking specific actions and states, allowing the agent to maximize long-term rewards. Okay. All right, well, what about Q learning versus reinforcement learning? What's the difference? Specific type of algorithm within the broader field of RL. Okay, so Q learning is just it's an RL approach, right? Machine learning paradigm focuses on agents learning, interacting with their environment. Concrete algorithms used to solve RL problems. Okay, so this is just an approach. Single specific algorithm, complete field of study. Strict value can be any value. Strict model can be any model. Okay. So Q learning is very specific to tabular matrix table. Okay. So it's just an approach. It's just an approach. We will explore at some point later in the future. Train an AI to create new data? Yeah, I don't know. Technically, yes. Yes, J-Bro, yes is the answer. Is it going to be good data? Man, I don't know. I don't know if it's going to be good data. I really don't. All right, so can we do a vec? Here we go. Cool. Okay. Okay. So we can do fish rocket. Can we do it without? Can we do this without turbo fish? Is there a way to do it without turbo rocket fish? Without turbo fish rocket, please. Can we use pub sub pattern with AI? Yes, you can. In fact, you can have the AIs talk to each other. Yeah, I can. Turbo fish, you guys. Yep, Vec 32. Okay, so let's just do this here. We'll just do that. Okay. Let tokens equal tokens dot tokens colon Vec F float 32 F32. Trained supervised learning. Supervised learning. Yep, that's what we're doing right now. We're doing supervised learning. Wait, how have you raised 154? Is that funding or have you earned? That's raised. Yep, that's venture capital, you guys. And it was 134. 134. You get the extra money in there. I see you sneaking in a few extra. Yep. You talk to the VCs, you guys. That's what you do. You talk to the VCs. Trained. It was training. But can you use the pattern to keep them updated? We can. Yes. That is something that I did work on a patent for, but I did not file it. It might still be worthwhile for me to file that patent. Kyle, you're talking about secret stuff. There. Let's see here. Where are we at here? Tensor from slice. Try into unwrap. Okay, fine. Try into. It's not my favorite, but it's not the worst. Okay. And then we will see if that is good enough. I think so. I think that might be good. Okay. Okay. So let's convert this into. Do I want to do an F32? Let me think about that. It's going to be logits, right? So are we going to get, do you guys remember? Thank you for the hearts, appreciate it. On our output, is it going to be, it's going to be integers. So this needs to be I64, right? Because we're doing I64 right there. Tokens, and then these are our tokens from the tensor. And then we need to collect over it. Okay. Tokens.iter. Map. Filter map. And then .collect. And this should give us a string, I think. Steven, you're such a great personality. Oh, thank you, Ashish. That's so nice for you to say thank you. You should be my AI professor. Ooh. Yeah, those AI professors, they like their math. They like the math a lot. And I'm more on the practical side of things. I like the applied theory, where we're writing code and actually getting things done. So I'd be more on the software side. J-Bro, it's a publicly listed company. Which one? What are you saying? It's a private cope? Yeah. Oh, yeah. My company is private. Thank you, Kyle, for the explanation. All right. So we need a filter map on this is going to be a token, right? It's be a token. And I need to say self.decoder.get the address of a token. I don't know if I need to do the address because it's just copied. Grab that, collect, done. I think that's it. right there. We might need to do an ampersand. Have to go. All right, Beast Hunter, good to have you here. Thank you for stopping by. I know we got started a little bit later today. Let me check my calendar to make sure we're good to go. on more stuff here. Okay. Okay. So we got 30 minutes. We got 30 minutes, you guys. We can finish this tokenizer today. See if this can build without crashing. It built without crashing? First try? Are you kidding me? No way. There's no way that worked. There's no way. Are you serious? Nope. I don't think so. Really? You guys think that actually worked? Look at that. Right there. All right, so let's try it out. There's no way. You don't get that lucky. You don't get that lucky with Rust. Okay. So we got our tokens here, which is, thank you for the party poppers, appreciate it. This is a tensor. So then let's get our string output. All right, oh, you know what we should do? What we should do here. Token, dictionary, tokens, okay. We don't need to throw everything into a token there. That's just a really big token. It's like a pretty beefy token, right? So instead, let's just do some test data. Let test string is going to equal, I suppose we could do answer. There you go. Well, answer. Okay. All right, we're going to say thank you, Kyle. You have base 44 add above your chat, by the way. I do? Wait, what? Really? Wait. You should be paid for that. I better be. Wait, yeah, maybe. We'll find out. I'll let you know at the end of stream. Hey, Kyle, thank you. I didn't know about that. That's crazy. That is crazy. They're advertising. They're monetizing me. On desktop, yeah. Really? All right. They're doing, you see what you're doing there, YouTube. I see what you're doing. Okay, let's keep going, you guys. All right, I want my tokens. I got my test data. Let's throw this test string in here. Can we do that? We don't need to put an ampersand on that. Test string. Looks good. We good? I think we're good. Okay, let's try building that. See if that's good. Whoa. Oh. Here. Okay. Boom. Boom. Easy. Yeah. Yep. Thank you. Okay. Nice. All right. Let's print out our tokens, you guys. Let's print out our tokens. So our tokens should not need to be the entire. This is text screen, so we should be able to print them out nice and clean. Should be a few, just a few, right? Yep. It's working so far, so good. Make them put that PubNovad on there. We should, yeah. I mean, really, we should be doing it. All right, you're right, Kyle. Actually, I'm with you on there. There are some opportunities there. We are just leaving those opportunities on the table. We gotta take up those opportunities. Okay, we need to print out our. We need to decode next. All right, let decoded equals tokenizer dot decode, and then we say our tensor. No, our tokens, I guess. Yeah, we'll call them tokens. Okay, tokens. See if that works. No crashing. No, that's oh wait, we called it dictionary. There we go. Yeah, okay. Print line exclamation point, and then I believe we can just say decoded. Can that work? Thank you, Kyle, right there. Look at that. All right, we built our encoder decoder. Our tokenizer is complete for a character level tokenizer. It is missing, of course, the batch iteration, which we can do through. We can figure things out. Go and sleep now. All right, sounds good. And Kit, thank you for stopping on in. You want to learn AI? Can you guide me, or can we have a nice conversation? Mohammed, AI is so much fun. It's great. It's one of my favorite things because you can train the computer to do work for you. It's the neatest technology ever. We could chat further. Send me a direct message on Discord and we can chat. A DM on Discord. Okay. So let's take a look at the code we wrote. All right. So we don't need to do that anymore. Let's keep it on the CPU for now. Yep, keep it on the CPU, looks good. See how fast that is? Oh my goodness, you guys. Oh, that's just so fast. And it's re-tokenizing. It's rebuilding the tokenizer every single time I do that. You know how long that took Python to do that? It took so much longer. You used to work as an embedded software. They ask a lot for embedded AI. Oh, well, you could do embedded AI. Yeah, that's actually really simple. You can do some really powerful small models. Some really powerful small models. Okay. So, tokenizer, here, I'm gonna mark this as done, and then we need to upgrade this here. All right, so let's do an upgraded tokenizer. We'll call this the upgraded tokenizer to word level tokens. There we go. All right, let's try that. Okay. Now, I'm going to, should I create a new tokenizer or leave the one that I have now or just overwrite the existing one? Let's find out. Here, source tokenizer. So this is what we built today. We built the collection hash map, the tokenizer with vocab length. We created a new. This is the faster quick sort. Dedupe. Our encoder and decoder lookups for O of 1 performance. Right there. Right. O of 1. Wow. Right, you guys. O of 1. O of 1. So good. Let's just do a dance battle versus Stephen A. And can you know about the dance battle? That was a real dance battle, by the way. It was real. Do you mean we use TinyML? I mean, how could we make that? Oh, Mohammed, what I would do is I just write my own framework from scratch. I just write my own from scratch for whatever embedded you're doing. You could probably, there's probably an already pre-built one for whatever target you're looking for. So you can do like a really small, easier one. I would do, because I've already written three from scratch AI models. Essentially what you call it, like without any frameworks. So it's like really from scratch, right? I mean, of course I'm using a programming language to do it, so I'm not using machine code by hand, you know? Hey, good luck givers, takers. Welcome on in, happy Tuesday. Good to have you here. We just built ourselves a large language model tokenizer and it worked. It worked really well. Got a couple of to-do items. There's some wrap-up things here. I want to turn this into a word-based tokenizer. So right now I did a character level tokenizer right here. And I want to convert this into a different kind of tokenizer. A full word tokenizer, which we can use regex for. Okay, where are we at here? So I want to implement this approach here, which is pretty, is that the one I want? Is that the one I really want? Yeah, I think I want to do that. All right. Regex, yes, okay. So this will be a new encoder. This is the new encoder. So we can capture all the data. Let's think this through really quick. So I want to, what would we call this? Vectorize? No, we need to parse it. We call this the parser. So let's create a new parser. And this is not a public parser, it's a private parser. So function parser, self, and then we grab our text, which is gonna be and string. And the output is gonna be something that I can use here. A vec of strings, maybe. Okay. I think a vec of strings, right? Vec of strings. Maybe. Maybe, right? Okay. Then, I guess we could do answer. That might be easier. String as string, which is gonna copy that out. So let me type that in. Okay, so this will be our regex. Let matcher, let's call it matcher equals regex. Hold on, is it re? Where is it? No, it's called regex. Okay. regex new. Call this a, what was it? I know there was a pipe dot \w. Is that right? Oh, we got to throw an R at it. Okay. There we go. Perfect. Okay. Are there any legal things we need to do before creating a release on AI? Nope. It's free software. It's free real estate, you guys. Like a privacy policy, like we do in Google Play Store. No, it's only if you have to do with data. It's only if you're dealing with data. Matcher, find iter. Okay, so it's a find iter. Okay. Let's see. Find iter. Wait, hold on. Find iter. Right. Matcher dot find iter. And then we have to do this on our text. Okay, then we map it. Okay. Map and collect. Hitting a programming plateau, and I don't know how to get to the next level. Is there a next level? Can you go further? How would you go further, Kyle? You already made it. And Schumann, good to see you. Hope you're having a great, wonderful day. You too. And Schumann, thank you. Happy Tuesday. Good to have you here. All right, so I need this to be a vec of string. You know what? We'll call this our words. I guess our word. They're not tokens yet. They're words. Maybe segments. Vocab. I don't know. I don't know what you call this. Well, let's say words. Return words. All right. Use of unresolved module regex. Cargo add regex. See if that works. Oh, doesn't like it. Doesn't like it. I don't want to use turbofish. I don't want to use turbofish. No. We do an answer. Oh wait. I mean, we have to do that later. How about no turbofish? It's the same thing. Okay. La la la. String next. M.as string. Okay. So it can't just use M. Maybe we say copied. Is that what we want to do? Copied. We actually have to put something in the map first. So let's say word. Try that. No, we're not gonna do it. Not gonna happen. No, Rust compiler. Not gonna happen. Next level is just specialization on a specific topic. Oh, Torva, that's a good point, right? You can go deep in, right? Like with AI or game development or data science or DevOps, right? Those are good options. Torva, you thought it through. Thank you so much for. All right, let me say dot copied. I don't think it's gonna like that. Okay. Oh, you guys, you're supposed to say, Steven, you did it wrong. You did it wrong right there. Look, you did it wrong. All right. Do we have to? Do we have to do that? Is that something we gotta do? Do you really want the matcher to be that way? Do you really want to? All right, hold on. Find iter map collect tokens vec of strings. It should be perfectly fine. It should be fine. What if we do as stir? The only problem is now it's going to be an answer. Do that. How about that? Why does it want me to expect there? Matcher. Oh. Right there, you guys, right there. See, now look at this, right? The compiler's all like, you should do a dot expect right there, which maybe we should, but it's like there's other ways to do it. Dollars and users versus money out of kind of mindset. Can you look at link share on Discord, please? Yes, I will, Loons. You are the #1 hackathon winner. All right, it's link share, you said. All right. This right here. TensorFlow, you mean my Quest 3 is still in the Netherlands. Wait. Oh, TF. Yes, okay. Expletive. Expletive, got it. The expletive, you mean, is still in the Netherlands. It's still there. It's still there. That's terrible. You ordered it. There must be some sort of customs or something. You had me at Netherlands. All right, where are we at here, you guys? All right, did we get it working? Oh, give me a break. That's not going to happen. We're not going to do that. No. I'm sorry. It's not going to happen. Nope. We're not going to do that. Nope. No lifetimes. To string. Okay. We're a bit closer. Method cannot be called due to unsatisfied trait bounds. Okay. Well, what else do we want it to be called? Are you going to give me a good answer? A back string cannot be into an iter regex match. Okay. So we need to convert that somehow to owned. No, doesn't like that. Okay. We have to figure out how to solve for this. La. Okay. Let me just put these side by side so I can see them a little bit better. Okay. Don't need to worry about that. Text is an answer already. Yep, we're looking good there. Backslash dots. Vector find iter text. And I called it matcher. Okay. Map.s. This is not, but we're not going to be doing a stir. We're not doing a stir. I guess we could try it. All right, we'll try it again. And stir. Okay. Yeah. It wants me to do lifetimes. We're not gonna do it. It's not gonna happen. Oh wait, hey Kyle, what did you say there? We can see some of your creative marketing side. You're also good at everything you've been involved with in the past. Oh, thank you, Kyle. That's nice for you to say. See some of your creative marketing side. So the most creative thing that you can do is interact with the communities where your audience are. So where's your users? Where do they exist today? Where do they go, right? You want to find places that they exist already. Then you need to figure out a way to integrate into them. For example, you've got a bunch of users maybe on Craigslist, let's say. Your users are Craigslist. So what you could do is you can create some advertisements that your users would see on Craigslist. You're looking at your UPS tracking and saw which means delayed in French. Oh, got it. American Mindset English. UPS was insulting you. Oh, you thought it was? I know. That was... Oh, Loons, that's pretty funny. That is a funny adventure. All right, so we're not going to be using lifetimes. Nope, not going to happen, Rust. You don't need it. It's not necessary. All right, I want to get this parser written and solved for right now. This is what I want to do. I want to solve for this, and I really want this to be a string. It can be a string, yep, and we collect. And then we say to string, right? No lifetimes. We don't have to deal with lifetimes anymore. Done, easy. Now there's not a trait bound that we've got a problem with. Regex match due to unstarted trait bound. Is it going to give me any information on this? Okay. We need a smidgen of help. Let's see here. This is when we jump in, you guys, and ask the AI for just a smidgen, because we only got 9 minutes. We could thrash on the keyboard for a while, but we only got 9 minutes. Still learning Rust. Yeah, the Rust book. Yeah, there you go. What am I doing wrong? I did say toString. Use .as stir here. Oh, are you sure? Oh, got it. Look at that. All right. Oh, we were like one. We were off by one. Look how easy that is. All right, there we go. Marketing fluff is bad. I get that, but storytelling is special. I really enjoy that aspect at work, even though I know it's kind of lame. I see the specialnesses of it. Storytelling, you are a CEO. Yep, you're a CEO, Kyle. You are. Scarlet Fire, you got it, Loons. Yep, Kyle, you're a CEO. You are a CEO. That's what they like to do. They like storytelling. You know it. You know it. Okay. We did it. Okay, so I want to try this out before we head out, you guys. We're going to try this out before we go. Let's go to our main file, and let's see if we can get our parser to do something here. And our parser is going to return. What's it return? I guess we're going to say public for now, because we want to use it. A vec of strings. Okay. Let test equals vec of strings. Our dictionary dot parser. And we're going to put in our, do we have test string? Here we go. And we're going to print this out. Print ln exclamation point the test. Okay, here we go. What do you mean? What do you mean? Cannot be formatted with the default formatter. Oh, okay. Well, then what if we made it extra special? Hey, look at that right there. Although it gave me letter by letter. It gave me letter by letter. And I want this to be a parser for word level. So it didn't. Hey, Donut Dude, good to see you. Welcome on in. Happy Tuesday. All right, Kyle, here we go. We got to turn that into words, you guys. I want to see this as some words. I need it to see as basically 1, 2, 3, 4, 5. It's gonna be 5 strings. It's gonna be 5 strings, you guys. So why this not work? Do we mess it up? Here we go. Here we go. Right there. Is that? Yes, we did. We messed it up. Okay. You guys, you're supposed to say, hey, Steven, you messed it up. Here we go. 5. There we go. That's what I'm looking for. We tokenized. We appropriately tokenized. We did it. Okay, this makes me really happy. Now, let's see if we can use our parser and our tokenizer really quick. Let's use our parser and our tokenizer. All right, so when we build the dictionary, we need to, instead of doing this, we need to do something else. We need to, right? Okay. So we need to run our parser right here on the new. All right, so let tokens, it's not chars anymore. That's gonna be a problem. Okay, we might have to save this tomorrow because we're not doing chars anymore, we're doing strings. Although we could probably fix it really quick, right? We could probably fix it really quick. We're gonna call it words equals, it's gonna be a vec of strings equals self.parser text. Is it gonna build? It's gonna build? Did we not? Oh no! We have to export this a different way. We have to put it up here. We gotta put it up here. There's no, we got no choice, unfortunately. This is the only way we could do it. And I suppose we could keep it a pub for now. So that way we can open up our main and change this up. We're not going to call it a dictionary. We're going to call this a tokenizer. Tokenizer parser. There we go. Okay. Let me call this parser. All right, build. And string. Wait. No. That's not a thing. Wait, no. Oh, wait. Do we have a self? We don't need self anymore. No, that's for encode. What about the parser? Parser. We don't use self anywhere here. Yeah, okay, good. There we go. That's what I'm looking for right there. World's so beautiful when human shows humanity. It can be very beautiful, right? It sure can. Hey, thinker nonstop. You guys are up there on the XP. Do you think I can beat my record? I don't know. I think you could if we stayed longer. Though I do have to get going. I have to get going because I've got some meetings coming up here. Let me check my calendar really quick, you guys. 1 second. Okay. We've got a few minutes left. We're cutting it close though. We are cutting it close. Okay. So we got our parser. Parser looks good. Happy there. Close this. Okay. I want to convert this to a word tokenizer. Let's see if we can do it. All right. So all these I64s, no, all the chars are going to get converted into different. We're going to do something different. Oh, we also have to sort. Okay. We can do a sort. We can do a sort. It's definitely, Beck's sort's got to be supported on a string, I bet. Probably, yeah. Let's do words. Words.sort. Words.dedupe. There we go. Okay. Yeah, all right. It's all gonna work. I think it might work. All right, so let's start, let's say goodbye to characters. All right, let's lock in, you guys. Let's lock in. All right, so we're gonna say string. All right. No. All right, good. Okay. Okay. String. Happy. And then, oh1, wow, character. It's not gonna be character. We have to change this now. We have to say words.enumerate, and this will be word. Maybe. We might not need to be ampersand. Okay, token, word, token, okay. Did we do it? The encode is gonna have to change as well, my goodness. Oh no, Vec64 is fine. We might have to change this. So the encoder is gonna have a problem. Yep, I knew it. The good news is we've got a pattern around here as string to string. Okay. So we might be able to do it this instead of copied. So instead of copied, let me paste this right here real quick. We're gonna say we can't say copied. It doesn't want the trait copy is not implemented for string. So what about cloned? Let's try cloned. Let's do an easy. It's not implemented. Fine. To string? No? Okay. We don't. Oh wait. Wait. We've been doing the wrong line all this time. On decoder, we've been doing it wrong. All right, so this is on the decoder, not the encoder. Okay. Whoops. Oh, whoopsie doodles. How about to string? Can we do that? Is that better? Okay, sure. Why not? I don't think that's not gonna work. It's not gonna work. Nope. No. So decode is going to convert it back into the string format. So I get my token, which is a vector I64. Hey, Porter, good to see you. Welcome on in. Time Griffiths, good to see you. You didn't say the magic word. Uh-oh. Hey, John Madden, good to see you as well. Welcome on in. You got rejected from art school? Oh, no. Bruce Lee, that's terrible. That is not good. Okay. We need to figure out where we're at here. So toString didn't like that. Okay, well, what if we did it the other way then? What if we said as stir dot toString? Yeah, what about that? It still wants it to be unwrapped. Why does it want some? Why does there does not need to be some? Expected enum option? Are we, because we don't need to filter the map anymore. Now we're on the encoder. All right, encoder. Perfect. Chars.len. Chars, la, around here. This would be words. Okay, that fixed that. Okay. We want ampersand there? Do you really? No. Really? Two string, all right. Do we need to? I think we do, right? Probably, right? Decoder.insert. Dot to string. We have to do that here too. We'd have to. There's nothing around it. Okay. Okay. All right. Did we solve that one? All right. We solved that one. Now we need to solve this here. Encoder.get. This is going to, we just need, that should be perfectly fine. The trait borrow character not implemented for, let's see, filter map. Here we go. So it does not like, let's try this. Wait, it wants it there though. It wants it there. We just need to borrow it for a little while. Just for a smidgen. What's the plan with this tokenizer? Sorry to be impatient. Hey, John Madden, all good. Yes, so we are going to be building a large language model. So this is a tokenizer for a large language model. We're going to be building this for rebuilding our large language model in Rust. Remember last week we built it in Python. Now we're doing it in Rust. Have you seen the Bad Apple virus? It's popping up all over the place. Bad Apple music video. Yes, I have. I've seen the Bad Apple music video. Don't think you can get Jurassic Park back online without Dennis Nerdy. Hey, Dennis. Hey, Tim. Tim Griffith. Yeah, I remember that was a good movie, right? Was that Steven Spielberg, maybe? No, I think so, right? Who did Jurassic Park, you guys? Do you remember? Okay. Trait borrow char is not implement. We're not doing char. We're not doing char anymore. We're doing string. We're doing string now, you guys. Okay. Where are we at here? Okay. Let me hide some things really quick. Let me do this. Let's just get rid of some things that we know aren't not good. No, this is always in the encoder. We're going to ignore the encoder for now. Did we solve the decoder? Okay. Encoder, encode here. Okay. Main. Okay. Let's just hide this for now. We don't want that. We're just gonna hide everything for now. Perfect. Okay. Oh, hey, all right. Okay, you guys. With the tokenizer, yeah. I thought we were going to non-standard approach or some optimization. Yes, we are building a more advanced tokenizer. Basically, we're gonna make it a real beefy one. Rather than a letter by letter, we're gonna give it some very specific meaning. These words that are gonna pop up in the right spot will have dedicated embeddings. They're gonna have their own dedicated embedding. Rather than being shared across the meaning, across a whole bunch of shared embeddings, it's gonna be dedicated. So that means our embedding model is gonna be a little bit bigger, it's just fine. And our token size will be smaller. So our vocab size will be smaller, which is gonna allow the model to learn better. It's basically, it's very common to do this approach. So that's what we're doing right now. And we do have to get going, you guys. We're gonna finish this tomorrow. We'll finish the encoder tomorrow. We'll get it to word. So we did character level encoding. So we did a really good job today, right? We did char level, character level success, right? We did this well. Tokenizer training, AM, okay. Let's see, tokenizer, char level done. We need to finish the word level, right? All right, push main, done, boom, all right. Hey, you guys, thank you so much for joining. Good to have you here. We'll be back tomorrow. We're going to continue to type really quickly and build our tokenizer. That's the plan. We're going to hammer it down on the keyboard. And then we're going to get into embedding, positional encodings, head, transformer, block. We're going to build a network. We're going to build an LLM, you guys. We're going to build ChatGPT. Hello, bro. What's going on? Hey, Abhishek. Good to see ya. We're headed on now. We got to get going. We are building a large language model in Rust. We're doing it in Rust, you guys. So as you can see, we're doing pretty good. So we just need to rewrite our encoder. We have to rewrite our encoder to be word level. Hey, bro, hope you're having a good time. Thank you, SSH. Good to see ya. How can I make income through coding tech? You're a dropout. Me too. I'm a dropout too. Enthusiasm. I would recommend going to Upwork. Just try Upwork maybe. Upwork is a good starting point maybe. Be a contractor. Bye. Good to see you guys. Thank you so much. Sounds good, Abhishek. All right. Thank you so much for joining, everyone. We'll be back tomorrow. More large language models, more Rust, more AI. That's the plan. We're building it. We're actually live coding it, you guys. Bye, everyone. See you, loons. Good to see everybody. See you tomorrow.